So in this example, we're given a circle. We have two secants that are meeting outside the circle at this point in, and we want to know what QN is to the nearest hundredth. So we're looking for the length of this entire segment QN. So I'm going to go ahead and label that as X. So this entire length is X. If we think back to the previous slides, I said to think about this formula as being the outer part of the secant, the part that's outside the circle, times the entire length of the secant. So X is representing the entire length QN. For the other secant, the outer portion is 13.2. So to figure out what the entire length of that secant LN is, I need to add 13.2 and 28.5. When I do that, I get 41.7. So now let's go ahead and set up our formula. So I'm going to take the outer portion, which is MN, so 13.2, and multiply that by the entire length of LN. I already added those two pieces together, so the entire length is 41.7. That's going to be equal to, for the other secant, I'm doing the same thing. The outer portion, the part outside the circle, which is 14.8, times the entire length of this secant, which I've labeled as X, and that's the length I'm looking for. So I'm going to multiply together 13.2 times 41.7. I get 550.44. 14.8 times X is just 14.8X. I'm trying to isolate X here, so I need to divide both sides by 14.8. So on the right side, 14.8 will cancel. That's how I'm isolating X. When I do 550.44 divided by 14.8, I get 37.19189,189, but rounding that to the nearest hundredth means 2 decimal places. So that becomes 37.19. Let's check and see if that seems reasonable. Comparatively, sure, 37.19, that looks like it should be a little bit shorter than LN, which had a length of 41.7, so that seems like a reasonable value.